Hey 8th graders, today you guys are going to be exploring net forces a little bit more using this pHet simulation called Force in Motion. So you guys have seen pictures of this before, but you haven't actually played around in this simulation. But you're learning targets. I can use unbalanced forces to cause a change in velocity of an object, and I can use balanced forces to demonstrate how an object will maintain a constant velocity. So yesterday we really talked about, this is what net force is, this is what a balanced force is, an unbalanced force, and we made predictions about kind of what changes in motions we might see if our forces are balanced, meaning that they would stay at a constant velocity, and for those that were unbalanced forces acting on an object, how we would either see an increase in velocity, a decrease in velocity for an object to stop, or if an object is already stopped, for it to start moving, or for an object to change direction. Okay, there's those 5 changes in motion that we see that occur with unbalanced forces. But what we're really going to dig in today is seeing this happen in real life in the sim. Okay, all right, so your warm-up for today is on slides 2 and 3. You guys are going to circle all that apply. If all the forces acting on an object are balanced, what change in motion of the object will you see? Circle any that apply. Okay, if all the forces acting on an object are unbalanced, what change in motion of the object will you see? Again, circle all that apply. And then on slide 4, you guys have your link to this simulation, so you guys can go ahead, right-click that, open that link up, and it's going to take you into the pHet sim. Today we're just going to be looking on the net force part of this sim. As we move through other parts of this, of like Newton's laws and the other chapters of this unit, you guys will see looking at motion, how mass, speed, those kinds of things all tie into motion, how friction ties in, and then even a little bit with acceleration. All right, so for today, you just need net forces. Okay. All right, here's our little tug of war, guys, that you guys saw in the net forces activity yesterday with the little candy cart. So you guys will be vying for the attention of the candy cart. And you guys are going to do it in a little bit unusual way. So you guys have a series of challenges to complete. And once you guys complete those challenges, you guys will screenshot them to show me you could do them. Okay, or to accomplish these challenges. So on your computer, you need to check all the boxes in the upper right-hand corner. So once you click on net force, we also need to have the sum of the forces. So that kind of gives us a value for our net force. Okay, and then also the speed of the cart. So as it starts to move, you guys can see how the motion of that or the velocity of that object changes. Okay, this is an example of a balanced force. Okay, so you guys can kind of again see what that looks like. And, sorry, let me just edit this really quick. There we go. All right, I feel better. All right, so once you guys have those checked, then you guys will go on to this first part. So you guys obviously need 3 screenshots here. I can tell by the 3 boxes and the 3 question marks. So using the sim, take screenshots to show 3 other examples of balanced forces. Challenge. If you can have one of your 3 examples showing a balanced force on a moving object, I'll give you an extra credit point, okay? You guys would show that by obviously having a speed on your little cart so it won't register 0. So again, you guys are going to demonstrate 3 balanced forces, okay? So set up your people however you choose, okay? Screenshot them. You obviously want to hit go so I can see that go is lit up and that it's working. And then once you guys have it working and it's balanced and you confirm that it's balanced, go ahead and screenshot those. Again, if you can have one that's in motion but is a balanced force, okay, and you screenshot that, I'll award an extra credit point. Okay, and then moving on, can you move them to different spots on the rope and change the balance force? So put 1 small blue player, so reset it all. Put 1 small blue player and 1 small red player on each side. So in this image up here, I kind of numbered each of the knots so you guys have an easy way to describe them. So can you move them to different spots on the rope and change the balance of forces? So basically that's kind of asking, is there any advantage being closer to the cart or further away from the cart? Okay, would that change the force of pull that these little dudes have when they are playing tug of war? So again, put 1 small blue player on one side and 1 small red player on the other side. Can you move them to different spots on the rope and change the balance of forces? So if you guys were to move one maybe from this position to this position, is it still balanced or does it become unbalanced? So that's really what you guys are asked there. So use your draw tool to circle yes or no. And then you guys are going to provide evidence for at least 4 examples. I've already provided evidence for one of these. So I put this example here, blue on number 1. So if I had a blue guy right here, and red on number 2, red guy right here, I look at my little reading up here and it says net force is 0. So this is how I provided evidence. So you guys want to structure your evidence just the same. So again, move your guys' blue and red guys to different spots. Okay, again, it should be in coordination with your prediction that you guys made right here. So is their force different if they're in different spots? Okay, yes or no? And then again, tell me where you guys moved your blue guy, where you moved your red guy, and what your net force was. Okay, so do that 3 different arrangements. And then moving on, let's talk about unbalanced forces. So here below, you have an example of an unbalanced force. You got the 2 little red dudes on one side and the 1 little blue dude on the left side. You guys are gonna go ahead, restart, and set up your player like this, or your screen like this, where you guys have 2 red guys on one side and 1 blue guy on the other side. Okay, you're gonna press go and let the game run for a few seconds, then remove one of the red players. What happened to the forces after removing one of the red players? What happens to the speed after removing one of the red players? So you guys will circle either did it increase, decrease, or stay the same. And then again, what happened here, okay? Next one, this is an example of unbalanced forces. Set up your game like this again. So again, 2 little guys, 2 red guys on the right and 1 little blue guy on the left. After you press go, let the game run for a few seconds, then add 1 of the small blue players. So we're gonna go ahead and add 1 small blue player to help this guy out. Okay, what happened to the forces? So look at these little arrows after adding the blue player. What happened to the speed after adding the blue player? So you're gonna circle your answer there. Okay, based on what you saw in the last 2 slides, if it takes an unbalanced force to speed up an object, could it also take an unbalanced force to slow down an object or reverse the object of a motion? So answer that question. What do you guys think? Explain your answer. Okay. And then after you guys explain your answer, you obviously are going to go test these theories out. Okay. So what you guys are going to do, you're going to set up, let me just fix that really quick. There we go. So you guys are going to set up your little guys so they're unbalanced. So if you start the game unbalanced towards red, so you guys can set up how it looks. It could look like this, okay? Set it up so there's 2 little red guys on the right, it's unbalanced, and 1 blue guy on the left. How can you guys get the blue to win? By adding people. So you are going to add people. You obviously get to decide whether you're adding blue people or red people, but your goal is to get the blue team to win. So once you guys have figured that out, okay, go ahead and screenshot that and put it in the after spot. Okay, if you start the game unbalanced towards red, so again, set up where you have 2 little red guys on the right and 1 little blue guy on the left. Okay, how can you get the blue to win? By removing people. So now you guys have to think of removing, screenshot after. Okay, and then finally, what is the most unbalanced start you can have? Can the other team still win? So you guys want to do your before is your really, really unbalanced start. Okay, and then your after is going to show you guys how you can get that unbalanced, clearly the losing team from the beginning. How can you get them to win? Okay, so you guys can kind of think about how you change the forces on that. Okay, then do your final wrap-up questions. Describe what the net force would be like if the blue team wins. Okay, would the candy cart show a constant velocity or a changing velocity? Okay, remember when we talk changing velocity, we're talking about one of those 5 changes we've been talking about in class. So speed up, slow down, start, stop, or change direction. Okay, constant velocity, if it's at rest, it's staying at rest, or if it's moving, it's staying moving at that exact same speed. It's not changing directions, it's not speeding up, it's not slowing down, but it is still moving. Okay, just like it was before we applied the force. Okay, describe what the net force would be like if the red team wins. Again, would the candy cart show a constant or changing velocity? Describe what the net force would be like if the 2 teams tie. Would the candy cart show a constant velocity or a changing velocity? And then do your wrap up. Do you have any questions? Circle yes or no. If you do have any questions, type them there. If not, leave that blank. And then 4, 3, 2, 1. How do you think you did? Okay, you guys are good to go. Have a great day, and I will talk to you later. Bye.